this semester. Not that you would notice, but I'm going a little bit out of order. I figured on the first night, let's just jump right into it and talk about some of the most important stuff. Chapter 2 talks about what is the systems development lifecycle. So let's go ahead and discuss that. So now granted, in 2 weeks you're going to read this chapter, but I'm going to cover it right now, and we're probably not going to come back to it very much after this. Today we're going to talk about what is the systems development lifecycle, what's in it. We're going to talk about methodologies, a whole bunch of stuff related to that. So I don't know how many of you guys, I might have, those that have had me in my other class, the MIS class, I might have shown this in there. So here's a little cartoon. So talking about a system that is theoretically, hypothetically being delivered to a customer. So obviously it's a tree swing, right? This is how the customer explained it. This is how the project leader understood it. This is how the analyst designed it. This is how the programmer wrote it. This is how the business consultant described it. And this is how the project was documented. That one's pretty clear, right? This is what operations installed, how the customer was billed, how it was supported, and what the customer really wanted. So the idea being that all along the customer wanted this, and everybody that was involved in the process of delivering this software all had a completely different vision and perspective on it. And wouldn't it be nice if somebody could determine this and communicate that all throughout the process? And that's really what system analysis and design is about. It should be that you as a business person can correctly understand what the customer is looking for and then communicate that to everybody else so that everybody else does their job correctly. And so that starts with the systems development lifecycle. And here are the phases. Now, different books will have slightly different steps that they use. For some reason, I always remember this acronym PADIS, P-A-D-I-S, Planning, Analysis, Design, Implementation, and Support. Sometimes in other books, they might leave off support, or they might have testing in there somewhere. So they'll have a few extra steps or a few less steps, but the ideas are the same. That the process of understanding what a customer wants and building it all the way through implementation is done through the systems development lifecycle. And we'll go through, and this class is hopefully going to get you very good at the project planning phase of this, the analysis phase, and then to some extent you'll get coverage and design, and really you just need awareness of implementation and support. So at a high level, project planning is you're trying to decide. So it's kind of a weird thing. Like planning, the word planning seems to imply that you already did everything that you need to develop a project or implement some system. But planning is actually a very limited word in terms of this SDLC. Really, the planning as part of this just means that as you discuss possibly doing some project, you kind of get a big idea, not the specifics, the big idea of what it is that you're going to do, and decide whether or not to do it. There are some other parts to it, but that's the main part. You just, without knowing all the specifics of the project, the software that you're going to maybe build, you just decide whether or not you collect enough information to decide whether or not to do it. And this involves putting together a business case. And hopefully, you as business people will be able to put together nice business cases. Assuming that it passes the sniff test, or it seems, without going into all the details, it passes this idea that you should be doing it, then you go on to the next step, which is analysis, and this is really the core of what we're doing in this class. Now you get down using things like modeling techniques and diagrams. You figure out in great detail exactly where things are, if you're improving the system, or figuring out exactly what needs to be built if it's a new system. So that's the analysis part, and that's the key part of this class. Design this is another one of those confusing words to me. Design is actually not building the software. It's not, and again, it's different from analysis. It's not discovering what the requirements are. Design is, in this case, it's modeling techniques that you can use to figure out how to build it. So one is what needs to be built, and another one is how to build it. Well, it's a little different. And then lastly, you actually build it, implementation, and then support it. So it makes sense that if you're going to build some software or some type of system, you'd want to think about all those things as you go from beginning to end. This diagram's not necessarily any better than the last list. Communicates the same ideas. I don't know why it has two different words for each thing. It just kind of clarifies it. But it's a different diagram that communicates the same idea. That you have planning, analysis, design, implementation. They have some slightly different words here. Testing and integration, evaluation. So this implies that the client is looking at it. You release it and then support it. And so then they have some alternative names around the edge here, or clarifying terms. But really it just communicates the same ideas. So if you go on Google, the SDLC, you'll get a lot of different diagrams that look something like this. So a lot of times I like to compare software to building just a regular home and think through just the logic of it at the high level. You know, before you build a building, you think about whether or not you should build it. You try and get an idea for what it should be like. Then you get real specific details of how you're going to build the thing, architectural designs, and then you build it. And then if you live it long enough, then you have to start maintaining it. That's certainly what's happening in my house. If I turn on the hose, water starts pouring out inside the house. I don't know why that happens, but one of these days I'll figure that out. Until then, I'm not using the hose in the front yard. All right, here's a different way of looking at the SDLC. All right, so going from left to right, we still have the same ideas: planning, analysis, design, implementation. This particular diagram has no support on it, but it gives some details about what are some things that are going to happen as part of this SDLC. And so here's some, so I'll just kind of walk through some of the pictures here. So as part of planning, deciding whether or not you're going to do it, the first thing it says here is you conceptualize the project. You're thinking of it in terms of something that maybe needs to be done. Well, hopefully we don't get too far off track here, but can you think of some system that hasn't been built yet that maybe should be built? Maybe at your place of work, or at the university, or an app that would go in the an online store. Anything you can throw out there?
I think everything that we do here at school should be integrated into one site. That would be awesome.
Okay.
I mean,
that would be good.
Easier. Might not. It'd be easier for us. Might not be easier for the school.
So we could think of a massive integration type project as something here, and that would be fine. Although to make it more simple for this example, it'd be good if we just chose one application. So maybe, so I'm just going to make something up here. You can probably already pay on your mobile phone, but let's just say that you can't pay for tuition on your mobile phone for the school. Now let's just say this is the first time you're doing it, okay? Then what you would do is you conceptualize the project. You'd be thinking about things like, okay, put together a request. Hey, I work, if you're a representative of the university or even just a student, I suppose, you could submit a request. And in the business context, you can have, businesses have a lot of red tape associated with them. So if they're getting requests all the time as an IT group, then sometimes they formalize it by saying, okay, fill out the form if you want this. And so maybe the form that gets filled out here is, we would really like to have an app which allows us to pay for our tuition online. And then the next step then would be initialize the project. So this, this request doesn't have all the details in it. It's just an idea. Over here, though, we start digging into it a little further. So let's just say that it costs, I don't know, $20,000 to build that app or to acquire that app. Before you go and spend all that money on it, you need to do a little bit more due diligence to decide whether or not you should move forward. So after it's been suggested, if it sounds interesting, then you start working on a business case around it. So things like, can we do it, and is there a monetary reason why we would do it? Does it decrease our expenses substantially such that $20,000 will pay itself off really fast? Or is it going to get us, new enrollment on such a scale that it pays for itself because we did this thing? And assuming it passes all those tests, so there's a number of them, we'll talk about them in greater detail in the class, in an upcoming class. Then we go on to this next step as part of analysis. So this is where we're figuring out our requirements, like what would have to be in a system or an application that satisfies this initial idea. And so you can create a whole, you can create reams of paperwork consisting of, hey, this is exactly what would be in this. Then designing it, instead of going from like maybe the business perspective, now you're looking at it from the software perspective. Like, what are all the parts that need to be into this in order to realize this initial idea here and have it fulfill all the requirements? We'll talk about that. And then you build it. Okay, now this is a handy-dandy breakdown of time that you're expected to spend on each step, and you will get, don't stress about it too much, but you will get tested on this. At least in one or two different places, you will get asked how much time is typically spent in the course of a project on planning, analysis, design, implementation. So here's how a hypothetical scenario would work. So if I were to say that in that as part of building the Pay Online app, that it took 100 days to build it, so you can work backwards on this. How many days did we spend on planning? 15, based on standard metrics. How many days were spent on implementation? 30. All right. So these are just some. These are some assumptions about how long something takes to get done in different phases. So it's kind of interesting to critique this and think about whether or not this makes sense or not. Because according to this, you've got 100% represented, and they're saying that actually building it takes 30% of the time. So does that make? What do you think about that? Would you challenge that at all?
I think it probably depends on what you're building.
Okay. So if you spend, so it could be 100 days, it could be 1,000 days, or if you're talking about man hours, I mean, it could be millions of man hours compressed over a given year if you have enough employees. So there's a lot of different ways you could look at it, but does it make sense that, okay, so that this is saying that if you had 100 days to build this particular app, that 30 days of it would have been spent on programming, but it took 70 days to figure out everything else before we were ready to build. What do you think?
I think it would depend on the complexity of the app, because
what if it was more complex?
the more complex it is, then you could run into issues to where it could not even be actually possible to do like a certain feature or something. And if the people who are thinking of the idea specifically know nothing about programming, then it could be impossible to do it. And if it's impossible, then they're asking for this and they can't do it. And so then there's going to be some back and forth. It's going to take them more time.
Okay. Did you have something?
I studied software engineering back in Brazil, and from my experience, most of the projects who spend too much time in programming, something's wrong. You have to actually spend most of your time prior programming.
Okay, so you feel that's a really interesting statement. So you're saying your experience is that if you spend too much time programming, that you didn't do enough time planning?
Yeah.
In essence, if we include everything else as if it were planning. So sorry, I'm messing with our words here, but after making a big deal about this is planning and it has a special meaning. But in a way, this is all planning leading up to building.
I say like pre-programming,
Yeah.
all the phases before programming. I don't remember like the specific reasons why.
Mhm.
But I remember it was like the gold rule of software engineering.
Interesting. Yes, Alex.
Yeah, I think he has a point, cause like, when I took that C# class,
Mm-hmm.
basically, in your planning and your design, well, planning analysis and design, once you had that part down and you knew what you wanted it to do, because you're supposed to have prior knowledge of what certain, programs, what certain codes would run certain things and how certain codes act. It basically depended on your design. Like if you wanted to put a Dropbox or a list box or something like that into your program, you had to make it go with the design. So it's
Okay.
basically, that was one of the, forgot what Ms. Hepner called it. But before you actually started writing the code,
Mm-hmm.
you had to make the design
Mm-hmm.
so that you'll know what you're writing the code for.
Okay. Now, and it might feel a little bit different in a classroom too, because they're trying to take a lot of the planning, they're trying to do a lot of that for you and say, okay, just learn how to write a loop, or just learn how to declare an integer and put it on the page.
Ms. Hepner didn't.
Oh no, it's on tape now. Okay.
She's a good teacher, she just wanted you to do it all.
Possibly.
Design it.
I haven't sat in her class, but there's a lot of ways that programming can be difficult. So if I were looking at this, I could I'll kind of look at this two different ways. On the one hand, I like what Ramon said, that if you spend too much time on programming, then maybe you didn't spend enough time here, or in other words, something's wrong. One of the first jobs I ever took, we spent the better part of a year reworking an application. Like, so some business leaders, they said, hey, we have this idea of what we want you to build, go ahead and build it. So we're on a team of people and we built it. And I must have built that thing 3 times. And every time they said, no, that's not exactly what we were looking for. And like, initially I was really excited about it, but then later on, I'm like, oh, this is taking forever. I'm getting depressed. Like, I went from being a happy developer to, I don't really like being a developer anymore. This is lame. And then we actually hired on a really good product manager. She interviewed people really well. She put down a specification of what we were supposed to build. We built that, and it was perfect. So like, that was a huge learning experience for me. I was like, whoa. So I could, be redoing stuff over and over again in my career, but if I don't plan enough. But it is possible in many cases to plan out exactly what you're supposed to do if you have the business skills, and then you don't have to rewrite it 3 times. I was like, wow. And that actually was I actually learned what she did and how she did it, and that was like one of the biggest things that ever happened in my career. So I just go throughout the work world, and everyone else is, they do things over and over, and they break things, and they don't plan right, and it takes forever, and me, I could plan. I could plan like nobody else could. It's because I'd seen it done, and it works. On the other hand, though, if I'm doing something all right, here's just another way of looking at this, though. All right, I've got 2 more ways to look at it. One is, if I was building something for myself, I really hope it doesn't come out to this breakdown. Like for example, I did one consulting project where it was more like 50-50, or maybe it was even 25-75, where I spent 30 days interviewing people. I scoped out everything that I needed to build, and they signed off on, yes, this is exactly what you need to do, and then I spent the 75% of the time, which was 3 months out of 4, actually making it, and everything was perfect. I never had any problems. So, at least in one particular case that I went through, I would prefer to not have so much planning time-wise. However, this is the standard. Oh yeah, and I was thinking of one other thing that kind of builds on this idea. Consulting. I decided when I decided actually when I was a student that I wanted to be a consultant. So I started going out there contacting businesses and saying, hey, I learned this PHP programming language and I know HTML and stuff like that. And so I would like to make applications for you. And so the tricky part was people wanted me to bid, well, the tricky part was putting together bids for people, because, and if you think about this, why would it be hard to put together a bid for a client? What does this imply? Why would it be hard?
Because those change.
Yeah.
They're never, that's not, if everything was exactly that, then it'd be easy. You'd just be like, all right, how many days is it gonna take? All right, that's what it's
Yeah,
gonna cost.
let's say it's a small project, it's gonna be 30 days long. But I don't have any, I don't know that up front. So what happens is at the beginning, I sit down with the client, they wanna sit down with me for 1 or 2 hours. So this is 30 days. So, but I don't know this. They sit down with me for 1 or 2 hours, and they wanna know, okay, how much will you build, or how much would you charge to build, what we just talked about? Why is that hard at that point?
Because you don't know how long it's gonna take.
Yeah, you haven't done any of the work yet. Like, well, you have to do the planning and the analysis. So if out of a 30-day project, you might need, at least 9 days just to figure out in sufficient detail what it is you're actually planning to build. So with some high-end consulting firms, so those being such as, like Deloitte, your accounting, the ones that are aligned with accounting firms and stuff like that, sometimes they will break up the project in 2 parts. They will have the first part, you pay for it, do the system analysis, and they might have a completely different firm do the implementation. That way, they're not, the idea is that nobody's getting cheated then. Because if somebody bids on how long it'll take, oh yeah, it'll take a year when it's really 3 months worth of work. The idea is people will be honest, organizations will be honest if you separate the analysis from who's gonna do it. So one person figures out what needs to be done in one group as a consulting project, and another consulting group actually builds it. But that at that high level, they realize you don't know that it's going to take 30 days until you're 9 days into the project, right? And if it's a much bigger one, so this is maybe just like a $5,000 project or something. But if you're talking about like a $10 million project or a $100 million project, it's you can't sit down for 2 hours and say, yeah, we'll sign a contract. We'll charge you $100 million and we'll have everything right. Okay, now let's figure out what it is that you want exactly. That's not how it works. It would be really hard. So anyway, but the only thing I care about is if I give you these numbers, at this point, is if I give you these numbers, or if I said, hey, you just spent 15 days on planning, how much time will the other steps take? You should be able to figure that out. But I'm glad we had a good discussion about what this means. Okay, we have this idea of a methodology, which is, so there are different approaches for how you would fulfill the software development lifecycle. Now, it seemed like it was pretty straightforward. You just go through an order, right? Planning, analysis, design, implementation, and support. But you could do it in lots of different ways. And the things that you can vary in terms of how you accomplish the systems development lifecycle, some parts of those are the techniques, the models, and the tools that you use to get that work done. There's a lot of different ways to do it. All right, just an introduction to things that we're going to do later, talk about later. So some models, or primarily diagrams, of how we will represent systems using an industry standard way of documenting things called UML, Unified Modeling Language. We'll do use case diagrams, class diagrams, activity diagrams, sequence diagrams. We won't do communication diagrams because those can be accomplished with that. We won't do package diagrams, but you could be aware of that. These are just all different ways that you could model the business environment and also model software and how it works so that it can serve 2 different purposes. And then in terms of, so that's just kind of requirements gathering type stuff for the most part. Down here, if you're going to manage the process, some other things that you would want to be good at are Gantt charts, PERT charts. This is about scheduling processes because like building a house, sometimes you can do things in parallel, like, for example, putting in carpet. You can put in carpet in different rooms at the exact same moment. But some things have to be done in order. If there's not a concrete pad laid down, you can't stand up the walls yet. So software is the same thing. And as you manage your software project and you become experienced at it, you get aware of all the things that need to be done as part of your plan, and as a manager, you then try to manage it and make sure that things get done in the right order, otherwise the release dates are in trouble. Financial analysis, those are other types of documents that help you in the process of doing systems analysis and design. Alright, blah, 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 blah. I don't think we need to talk about this one. Here's a couple different names for approaches for how to look at things. This will just be a little thought exercise here for a minute. Alright, so let's just pretend that, alright, so I need a context. Let's try Uconnect registration. Okay, so within Uconnect, I believe you can do registration for your classes. If you were trying to understand from a software perspective how the Uconnect registration system works, let's talk about which would be the best way to represent that. One way to represent that would be the process perspective. Now, process perspective, you could say, well, in terms of how this works, we do step 1, step 2, step 3, step 4. So you might talk about it, okay, so talking about it from a user's perspective, you might say, you know, I log in and I click on a certain link and I do a search and I click something else. So you could just continue on with that. With a process, I could write it down as a list of items, but I can also, there's also some other ways I can do it. I can use it, I can do this pictorially or graphically rather than just a bulleted list. So oftentimes for the steps you go through, we will use something like rectangles are very common. So we might write these words in rectangles, and this is particularly useful if there are, you know, kind of decision-making points. Like maybe there's I'll draw a little diamond here, and I'll have a little yes, no coming off. So maybe you have to make some decision after you do a couple things, like maybe you did your search and you need to search again, yes, if yes, go do this, or maybe go back there, and if no, then continue on to this box. So there's a process perspective of how to understand the Uconnect system. There's another way you could look at the Uconnect system, which is data-centric. So if you're taking some type of data resource management class, you should know how to draw a table of some sort. So you might write, so one of the entities involved with registration would be a student, and another type of entity involved with registration would be a class. And so for these things, you could write out things like your ID, your name, that sort of thing. For the class, you could write down the location, the time it's available, the subject, and these things would be represented by things like integers and characters of some sort. I can do the same thing with, and there's also maybe a date as a different type of field. All right, so if I were trying to understand, get my head wrapped around how Uconnect works as a system for the first time, which one do you think is better, the process perspective or the data perspective?
Probably the process.
Process.
Okay. Would there be anything bad about not including the data-centric perspective in your analysis?
Repeat the question?
Well, if you only considered the process and you didn't consider this when trying to understand the system, is there any downside to that? What do you miss if you don't know this?
All the information, things like data types and stuff like that. Is that what you mean?
Yeah.
Oh, okay.
Well, you don't understand all the data that's in the system. I mean, this shows the steps that you go through, but yeah, how much information, what information is required? So this gives you a perspective of it, and this gives you a perspective of it. So I asked it as an either-or question, but really, it'd be nice to know both if you're really trying to understand the system, because if you were just describing this verbally to somebody else that needed to write this or create it for the first time, they couldn't work on it with just this. Like, they can't actually build anything unless they know every single field that's involved with this system, all the data that needs to be captured. But if you just talk about the data, that doesn't give any idea about how the system works in terms of how you move through the system if you're a user. So this tells you what's in it, which is critical if you're developing a system. This tells you how it works, which is also critical. There's another idea here, a way to represent things, which is the object-oriented one, and that's what we're going to build into the class. So the object-oriented perspective for representing a system is very, well, we can actually build off of the data-centric perspective and sort of this process perspective. If we look at things in terms of objects, we'll learn more about what those are in the future. But if we have a student, not only do we, as some entity in there, ID, name, that's data that is represented by a student. But then when we do our diagrams related to students, we also put in there what that particular entity can do in the system. So in this case, one of the things they might do is like register, add class, oops, sorry, drop class. You don't have to memorize this at this point. But one thing we do with object-oriented ways of representing things is we indicate the data as well as what it can do, the different entities that are in a system. And then there's another thing that we do is we draw it out like this, side by side, student and system. And then we draw lines back and forth indicating what's happening. So maybe if this person like adds a class, then it sends back a confirmation. So in addition to this perspective, we also have this object-oriented perspective that we're going to get into in the class that gives you just a different perspective of how systems work. So I asked this cruel question, which one do you think is best? But I'd like you to consider, it's kind of a trick question though, because we don't really want one to be the best. We probably need all of them if we're going to understand things well enough to make a good system. And it's too dark for me to see that on there. Maybe I'll do that at the end of class. So if somebody watches this someday, I'll turn on the light at the end. All right. So if you grow up in Oklahoma, you're concerned about things like, do I like Oklahoma State or University of Oklahoma, or do I hate Texas? And so if you're a software developer, there are some other things that you debate about with other software developers. Things like, do I want to use Microsoft products or do I want to use open source products? And potentially you could also argue about, do you want to follow a predictive approach to the systems development lifecycle or an adaptive approach? Although it probably shouldn't be a debate. And I think mature, sound people are able to understand that. So there's actually two significant paradigms or approaches to looking at the systems development lifecycle. One is the predictive approach, which is this approach that you use when you understand really well what the system needs to do ahead of time. So in the case where we were talking about building a payment application for registration, that would be something we could understand very well, very clearly. There are a lot of things software-wise out there, though, that we don't necessarily understand very well. And if we don't understand what we're going to be deploying or delivering ultimately very well, then we have a different approach. And so we'll show some examples of this with diagrams in the upcoming slides. So, I mean, this one, in short, the predictive approach just means that you kind of draw out all the plans ahead of time because you know that nothing's going to come up that you don't understand. because it's a very understandable problem. But over here with adaptive, that means you're iterating in most cases. Like, you know that you don't know enough about the problem to actually solve it. And so I'm trying to think, what would be some good examples of an adaptive project? Okay, enterprise resource planning systems, if you've heard of those, tend to be something in this category. When you talk about a system that is so big, it spans every single function in your entire company, or at least the financial ones, and it can span operations, customer relationship management, supply chain stuff. It can handle all kinds of things, and at a $1 billion company, you're talking about tens of thousands of processes that are going to be encompassed by some system that just gets dropped on some existing company one day. And so when a consultant comes in and tries to interview the business, the multi-billion-dollar company, it is almost impossible for them to account for every single thing that could possibly go wrong. And so you just, oftentimes you'll do iterations. You figure out a piece at a time and get that right. So maybe a different thought, though, maybe a far better example, because that's actually more describing an agile approach to things. We'll talk about that terminology in a minute. Maybe a better example for this would be if you were the first person who ever created like a spreadsheet, for example. Now, if a spreadsheet's never been created before, if you're duplicating a spreadsheet for like the 100th time and just knocking it off and trying to make your own version of Microsoft Excel, you can plan that out. But if nobody had ever made that before, and you're going through iterations with customers, that's when you use adaptive stuff. And in businesses, a lot of times you're doing stuff that's never been done before. So maybe you're working in an energy firm, and you're like, hey, what if we do like this mobile thing that works out in the field when we're out on the rigs, or 100 other things that you could use in energy production that's maybe never been done before, but is made possible by new technologies? That might be adaptive stuff. Like, you're like, well, hey, let's try this out. And then you go out there and you're like, well, okay, well, this is cool, but the font's too big, or it's too small, or I can't enter in things right. And so then you go back and say, hey, it was a good try, but let's try it again. So that's really what adaptive is about, doing things oftentimes for the first time. Okay, so this is a much maligned term as it relates to software development, the waterfall approach. In waterfalls, in the real world, water flows downhill. Here's our cycles, our phases: planning, analysis, design, implementation, support. The idea with a waterfall approach is that you move linearly without going back. You just go step by step. You don't ever go back. You get one thing done, go all the way through, and then the project's over. So you get a high idea of what you're supposed to do. Then you go into figure out the specifics of what you're supposed to do. Then do the specifics of the software design, and then you build it, and then you deliver. So the reason why this is maligned is because it used to be, particularly in big government, it used to be the case that there would be like 5-year-long software projects. So Department of Defense, for example, has all these $300 million type projects that they get several years into. They've got 1,000 or more developers on it, and this happens all the time in government, and at least here. And so they get several years into stuff, and they get there's somewhere down here. It's 5 years after the fact. They collected their requirements 5 years previous, and they go to deliver. And what does the business customer say?
It's 5 years old.
Yeah, it's 5 years old. We've been adding on new systems for 5 years. So they're, so it could be like a retirement benefits system or whatever it is. Yeah, the world's been changing for 5 years straight. They collected their requirements 5 years ago, and now whatever it is that they've delivered or are about to deliver just really doesn't.
It's outdated.
Yeah. So it's a total disaster. They scrap it, they fire everybody, and then they give up on that. They go on to their next project that maybe is going to be canceled someday. And so that's not as big of a problem if it's like a 1 month project, right? You could probably go through this successfully in a 1 month project. But if it's something that's going to take 5 years, the scope of it is so big that there's a lot of risk in approaching things in this fashion. It's just too much. It's too much to bite off if you're going to make it really big. So today, typically, organizations try to target like a 6 month project or something like that as their size. so that if they're going to try and do this approach, that they've got a greater chance of hitting it or failing earlier. All right, so this is the waterfall approach. People complain about it because it, you know, if it's a really big long-term project, oftentimes you don't get what you need. And it's ironic that everybody hates it so much. This is a book from a game design class that I went to once, and they talked about the waterfall methodology. They said, interestingly, in the original paper about waterfall, the creator emphasized the importance of iteration and the ability to go back to previous steps as needed. He never used the word waterfall, but what has been taught at universities and corporations everywhere was this linear approach. So ironically, waterfall is not a real thing. You're always supposed to be able to go back. Anyway, here's some variations on this waterfall approach, which again is a very good approach if you can understand what it is you're supposed to do ahead of time, which I think is a lot of cases. So here's the main approach. You just go step to step to step and go on through, and everything's great. Here's the parallel model. So this is just like that, except you get to a certain step and then you break out the work into 3 different teams. Let's see, what would be a good example of this? Aha! Got a great example. All right, so I don't know how many of you look on ESPN all the time. I, for some reason, waste time on there every day of my life. Not sure why. So one of the cool things they have on ESPN is they have this little thing up here where you can look at any game. Hey, you're supposed to be able to mouse over it. Oh, there you go. Supposed to be able to mouse.
I think because those are still going on.
Yeah, I should be able to get the. Don't know how. Maybe. Let's see if this works better in Chrome. Usually the. Same thing. Weird. Alright, so if I go to Gamecast, so if I mouse over this, I click Gamecast. For those of you that have seen this before, hurry up. In the meantime, alright, so imagine that your tool, the tool that you're speccing out as part of your organization, you say, hey, wouldn't it be cool if, while games are going on, we could show a graphical diagram in real time that shows, you know, who's doing what on the field of play. Now, the way that looks for basketball is different than how it looks for ice hockey, and it's also different for how it is for football and other stuff like that. So you can watch in real time these digital graphics of games that are going on, but it's different how it's implemented. And so I thought that might be an example, that could be an example of this. Maybe you're creating that feature for the first time, you say, hey, wouldn't it be cool for all of our sports, we made it so that you could watch things in real time. So you plan all that out, but then you break it out into separate teams for implementing the score thing for the different sports. So you do it in parallel. Like, you have the main idea, you know what you want to do, but you got to do it across all the different major sports now. Here's another approach that, again, builds off of Waterfall. We've got the phased approach, and the phased approach is just saying, is this saying step through all of the things over and over and over again. Now this one was important to me as a manager because like one place I worked at was an e-commerce company, and what we did is we sold websites where people could go in and upload all their products that they were selling, and then they'd be able to sell it to the, you know, they'd have their own unique website URL, and they'd sell to other people in the world. And when we'd sit down with customer service, who was always talking to customers, they'd say, "Hey, we'd like we'd like this feature and this feature and this feature and this feature in our service, or in the website." And as we'd sit down and think through that, as to, we had a limited staff, we said, well, if we did all of those things, it will take 2 years. So if we want to have our next version of the software, it will be 2 years before we release that. Then we said, well, what's an alternative approach we could take? And so one alternative approach we would take is, well, what if we broke that into sections? They'd say, okay, well, what could you give us in 3 months? Could we have a new iteration in 3 months? And then we'd negotiate, okay, well, here's the subset of features that could go into 3 months. And so that would be kind of a phased approach. We'd say, okay, let's talk about our rollouts for the next 2 years. This is what we could put in version 1, version 2, version 3. And so it's just an adaptation of the waterfall approach. Now if we start down here we get over to more of an adaptive approach to things. This one implies that you plan, analyze, design, implement. So basically you go through the steps and you build something, but instead of having it be the final system, it's considered to be a prototype, meaning it's something that you want to put in front of a customer or business client to say, hey, is this what you were looking for? And if they say, yes, this was perfect, then you roll it into final production and out it goes. But if it's not right, you just loop over this as many times as you need to. And so this adaptive approach to building software is good because some of the benefits it has is you might try and do that whole sequence in the course of a month, particularly in a area where you're not used to building that type of software. I think one thing I like are video games. So I think this would be a good approach for maybe doing mobile apps and stuff. So you do a good plan, you say, okay, is this game cool? Then you play with it, and you're like, oh, well, it's got these usability issues. So you keep on working on it and working on it and working on it until it's right. And so this prototyping approach is a good approach for many types of software. This represents the same idea. It's labeled spiral model, but it's the same thought as it relates to prototypes. Again, it assumes that you don't know exactly how you're going to build it or what it needs to have in its features up front. So you build the first one, then you build the second one, just do it as many times as you need to. Agile development is a big buzzword. Around 2000, 2001, there was this big pushback against against waterfall approaches because of all the failures that were had. And so now, if you talk about software development or read about software development, just about anywhere, they all talk about agile development. And agile development, it's a more adaptive approach to software development. There are very specific things about it that I don't want to go into all the details, but just at a high level, it allows you to kind of do that more, much quicker iterations on building the software as if you were prototyping. Go through the whole process, figure out what you're supposed to build it, and that way, the idea here is that if you spend 4 weeks creating an iteration, a working version of the software, you put it in front of the clients in front of 4 weeks, and they can give you a course correction for whatever needs to happen. And contrast that with like the Department of Defense, where you might, those projects where I was saying they're 5 years down the line. So they're saying, hey, let's get your course correction 1 month in, rather than having it fail 5 years down the line after you spent $300 million. Anyway, so this one says you develop functionality 1, test it, develop 2, test it, and in a very short amount of time, you demo the release, get their feedback, and then start all over again. And then visually, here's the waterfall approach again: analyze, plan, design, build, implement, support, whatever. If this is a timeline for how long it takes to go through something, conceptually, Agile is supposed to, make a much shorter version of that, and you go through here, and you go through these phases of design, build, test, and deploy. So, 1/3 of the way through, you have working software. That's one of the key tenets with Agile too, is that you have working software on a regular basis. If this is waterfall, you might not have working software until 5 years down the line, 6 months down the line, whatever it is, the length of your project. The thing with Agile is you have working software, potentially every 4 weeks or sooner as you look at a timeline. And then this allows for real world things like requirements changes. Customer says, hey, I'd like a mobile aspect to this application that you're building, or I'd like to build in GPS, or I thought of something else. We've got a new customer base we'd like to address. Well, you can build that in right in the middle of the project if you're building working versions in and delivering them on a regular basis. Need a breath. All right, if that doesn't get you excited, no, it's pretty late, so I'd be surprised if you're not struggling at this point. Here's an advanced approach to systems development. We have that very simplistic view of designing things, of building software and systems, planning, analysis, design, implementation, and support. Some people thought about that, and they found a way to make this even more complex. So here it is. Another way of looking at it is renaming our steps. We'll have an early phase of developing our software called inception, and then elaboration, and then construction, and then transition. It's still the same idea that you think about building it, and then you plan it, and then you build it, and you roll it out. So that is still the same. However, these little boxes each represent a full cycle of the systems development life cycle. A full run of planning, analysis, and design. And so here's a visual way of representing that. So imagine, for example, that each of these columns represents 4 weeks. Then this project takes 1, 2, 3, 4, 5, 6, 7 times 4, 20. This looks like a 28-week project potentially laid out here. Here are some of the components of coming down this way that are part of your typical systems development lifecycle. Collecting requirements, designing, implementation, testing was kind of part of what we talked about. So the unified process said, there really are actually all of these things, all of these skills are involved with delivering software. And so as part of a given 4-week iteration where you go through the whole cycle of planning, analysis, design, implementation, we need all of these different skill sets to deliver a working iteration of software at the end of that. Furthermore, as you move farther and farther into the project, you need more of some type of skill sets the later you get into the project and less of some others. And so that kind of makes sense. So if you're collecting requirements in terms of what, for example, one skill set you need is to collect requirements on what you're supposed to be doing in your system or the project that you're delivering. So it kind of makes sense that early on you ramp up pretty quickly, and on the early part of the project you're collecting requirements, and by the end, the second half of the project, you shouldn't be collecting requirements anymore. So this one's saying, well, you might be doing a little bit of that, but it should have tapered out by then. The bulk of your work was early on. Similarly, if you are deploying the software into production and you have processes for that and specialized skill sets for that, you shouldn't be worrying about, you're probably not doing as much of that early on as you are at the end. Implementation, we talked about that as building, actually writing the software. Well, you can't build something that you haven't planned for yet and gotten the requirements for it yet. So obviously the programming doesn't ramp up until partway through the project, and then it stays really high throughout the end of the project. So this is a good thing to be aware of, that this is a different way of looking at things. The unified process is a very high-level, complicated, corporate way of looking at major projects. As you work in different organizations, if you're involved with software development, they may have different approaches to doing the systems development lifecycle. The unified process is one approach, but some organizations will have something, they all incorporate the same ideas, this planning, analysis, design, implementation, and support, but the way that they represent it, the way that they suggest you manage that process will vary in specific ways to each approach. And so you might work for an organization that's either created their own approach to managing the software development build process, or they might buy it from somebody else and spend tens of thousands of dollars on training and written materials that allow them to manage their whole software development cycle that way. So you never know what you'll get. This is a kind of a complicated one. I don't necessarily want you to memorize this one, but it is good to be aware of it because it's realistic. That it does actually take all these skills in order to deliver software. Like you need project management skills. You need deployment into a working environment. And that's different than writing the software skill, and that's different than collecting requirements skills, and that's different than different types of modeling that you might be doing, diagramming related to the business environment. All right. How do we want to spend our last 20 minutes or so? Probably at home, right? How can we
On the
speed?
way home.
Yeah, that's how we like to spend it. How can we speed things up a bit? Well, sometimes in class, if I'm looking to kill some time, one thing I'll do is and also it's kind of, I try to give you guys activities to do in class, because if I do all lecturing, I know it's not very much fun. As a professor, I oftentimes get put into educational environments every year where I have to go listen to someone else talk. Let me tell you, we professors, we're the worst at listening to other people talk. We're just like, can we sit in the back and play on our iPhones or something, or iPads? So yeah, we feel your pain. We're the same. Anyway, usually I'd have you do an exercise like this one in class. So what I would have you do if you were really doing this is, here are some different approaches to doing software development, to doing the systems development lifecycle. Some things like test-driven development, prototyping, Scrum, extreme programming, rapid application development, agile programming, spiral, iterative, waterfall. We've in the unified process, so we've touched on a lot of these already, but I think but for the most part, we've captured the ideas in there. Some of these are more for situations where you understand well what it is that you're going to build ahead of time, or at least you can plan it out well. And others of these are for situations where they can't be planned out as well. The Scrum approach, though, might be, I might forget to mention this near the end of the class. The Scrum approach, that's an important aspect of Agile programming that you may be exposed to if you're involved with anything system development related. And that's the idea where you get together every single day as a project team and you just have a quick little huddle and discussion to make sure that nobody's stuck on anything. When I was managing software teams, initially I was trying to meet with people like once a week because I wanted to go do other things. I wanted to go visit other sites and collect information and do all kinds of business activities. And so I'd make a plan with my developers and I'd come back a week later and they'd be like, oh yeah, like 4 days ago, I didn't know what to do about this. So I didn't do anything on it. I'm like, well, why didn't you come talk to me about this? And it was the most frustrating thing. Or another thing that might happen is they would just go do something dumb. Like, why did you do that? This is already built into the software. You don't need to write that function. This already exists. And so by having daily meetings, the Scrum process, that's kind of a more modern approach to managing development, which I think results in getting things done faster and with higher quality. So here's this nice grid for when to use what type of approach. So we talked about waterfall, parallel, phase. These were all kind of waterfall-based approaches. And then over here we've got prototyping, and then we have agile extreme programming is one version of agile programming, but it kind of has a lot in common with this other topic here. Anyway, these are more of your agile adaptive approaches, and these are more of your predictive approaches. And so you can kind of see through here, you know, based on different things. If you're not sure what you're doing, what you're going to be doing, you don't want to be doing these things. But if you're not sure what you're doing ahead of time, these are great approaches. If you've never used the technology before, maybe it's your first time writing an iOS app and you're using Objective-C, you know, maybe this is a bad approach, and maybe this is a good way to get into it. If it's, let's see, if you have don't need to talk about the others. Anyway, so you might think about reliability, schedule visibility. I think the most important part is probably just the requirement clarity part. All right. Just kind of an informational thing that's interesting. One of the tools that's available out there for you to use is there's something called a code generator. And if you draw your diagrams right, based on what we're going to talk about in this class, you can draw diagrams as a business person. And there's software out there that, based on correct UML diagrams that we will build in here, will write the code for you in Java or C#. So that's some pretty cool stuff. So it'll stub out, it'll write most of it. So at least all the big parts. When we're talking about major entities or things that are part of your system, like the student and the classes, if you're talking about registration, there's software out there that'll write that stuff for you if you do the diagram right. Just fun to know. All right, here's a statement. With all this SDLC structure and methodologies, statistics show that over 1/2 of development projects fail to meet their objectives. That's an interesting fact. I could ask, should we always implement a full SDLC in all projects? But maybe let's talk about that next time. Let's jump over to the homework real quick. Okay, so we just got through talking about the systems development lifecycle, planning, analysis, design, implementation, and support. If in your book you go to figure 2-3 on page 41, you will read about the objectives that are supposed to happen in each of the phases. I have an exercise based on playing with that and understanding that. So here are some websites where there are projects listed, IT projects that are currently going on. So if I click on one of these, all right, here's a list of projects. Maybe we'll talk about this a little bit more next time. Active projects, pending projects, proposed projects, archive projects. This is what project lists look like in enterprises around the world. This is what my project list looked like when I was managing a portfolio of projects as an IT manager. We'd have lots of different projects that were in progress or upcoming or had been completed. If I click on, I can see who requested it within a large organization. I can see potentially when it goes live. Okay, this one says automated travel authorization process. So if I click on it, let's see what this one tells me. All right, so it looks like over here there's a project request form that somebody filled out. Cool. And in here, they argue like why they want this project getting done. So early on, didn't I write that somewhere? Anyway. Okay, so there was that slide with the different colored columns on it. Here's this form that you would fill out to argue why you want something to get done. And then there's this project scoring worksheet. So this appears to analyze whether, again, part of the planning phase, argue whether or not it should be done, I would guess. It assesses the risks. And if it passes that, then they're ready to go on to the next phase, which is figuring out all the details for how you would do it. So this collection of documentation regarding a project covering all of the steps of the systems development lifecycle is available on many different websites or in many different organizations around the world. What I want you to do is, I provide you an example of what to do. Look at a site where there's a project, and then I want you to write something about each of the steps in the systems development lifecycle. Write a few words about project planning, about analysis, about design, about implementation, and about support. So specifically, what do you see in the project documentation that shows that they follow best practices for that? So you might have to review this when you get home because it's late. But if I look at project planning here, it says, as part of project planning, you're supposed to identify the scope of the system, I mean, how big is it, ensure that it's feasible, that's what that scoring document was about, develop a schedule, resource plan, and budget. So what you do when you look at a project is you say, for this project that I just looked up, I can see evidence that they looked at the scope of the system. I see evidence that they did a feasibility analysis. They maybe did or didn't develop a schedule and a resource plan. So just talk about those things. It's not supposed to be super long, but it is supposed to be specific. So you don't just say they identified the scope of the project. In this case, for example, one of the ones that I wrote about, they had a form on their main university website as part of this one, and they said that they wanted to update the fields that you could fill out as part of the help or the inquiry form on there. So it's not very complicated, right? Nevertheless, they went through the whole process with it as if it were a project. And so I wrote on here, they identified the scope of the task as changing the web form details for the contact page. They estimated the feasibility at some point because they estimated it would take from December 8th to February 26th to accomplish. So anyway, so I look at the objectives of what you're supposed to accomplish in there, and I just check to see against the project details what evidence there was that they met those objectives or addressed those objectives. Does that make sense? So you go down to the next one for analysis. What's supposed to happen in analysis? Anyway, so I provide you an example of that. You shouldn't have any problem with it. So that's what I want you to do for next week. You do it for 3 different projects. You just write up a little block about this big for each one, and then you're good to go. All right. Any questions? So this will get you out of here like 10 minutes early. Hallelujah, right? So I try to get you guys out of here around 10 o'clock most nights, particularly as we get later in the semester and you're working on your projects. That allows you some time to come and talk to me either, well, ideally you talk to me earlier, like during a break, but if you need to, you can talk to me at the end of the class about your project status, and I can look over your diagrams and stuff like that with the time that we have at the end of class. Any questions on anything? This is your homework assignment next week. Do that in the readings indicated in the syllabus. And also fill out your study guide for next week so you can take this open note quiz. Questions? If not, then I wish you a good night. See you next week.
All right, here's the documentation that I put up earlier. We got just some diagrams of writing down a process, what that might look like, the data approach, data-centric, and then some information about objects. And earlier when I was talking about the breakdown of calculating standard system analysis and design times in each of the phases. Just some notes on that kind of stuff. And that's it.